Good afternoon, and thank you for joining me on this lovely Monday afternoon. Thanks especially for coming to this AIM Science Facebook Live event. I'm going to be here every Monday at 2 with some fun science experiments for you to do. So we know that science is best if we can do it, so it would be best if you could do these with your kids, or if you can't do them yourselves, then at least watch them at home. So our projects today are going to involve vinegar. Vinegar is an amazing substance. It's a liquid that is made of water and an acid. That acid gives vinegar a very tart, sour taste that's just perfect for things like salad dressing and pickles. But vinegar is also something that is really a lot of fun to play with. And on this day, we're going to do some experiments to use vinegar in a couple different ways. The first thing we're going to do is we're going to make plastic out of milk. Can you believe that? When you mix milk with vinegar, a strange thing happens. So let's take a look. I'm going to tip the screen down so you can watch what I'm doing. All right. So the first thing that we're going to do is we're going to heat a cup of milk in the microwave. You want to heat it for about 1 to 2 minutes. You want the milk to be hot, but not boiling. So mine has already been heated, and I kept it hot in this thermos. So we're going to measure out 1 cup of milk. Then I'm going to put 2 tablespoons of milk. I'm going to pour it first into this beaker. Actually, this is a piece of science equipment. It's called a beaker. And if you have them, they're really fun to use. If you don't, you can just use any kind of clear glass jar. You don't want to use metal when you're using vinegar. So we'll pour this into the beaker, and then we're going to measure out 2 tablespoons of vinegar for every cup of milk. We're going to keep adding more if we need to, but I don't think we'll need to. So let's put in 2. Now I want you to watch closely as I stir and see what happens. Can you see how this is curdling? The liquid is coming out and we're getting chunks. So those chunks are the curds, and the liquid is the whey. So the next thing I'm going to do is I'm going to separate the curds and the whey. I'm going to pour it into a fine mesh strainer. Now, if you don't have a fine mesh strainer, you can use a regular strainer, one of the kind with the big holes, but you'll need to put a paper towel in there. Otherwise, all your curds will go right through. So I have a fine mesh strainer, and I'm going to pour the whole thing into that strainer. And you can see it's pretty icky and gooey. And all the liquid came out. Now I'm going to use my spoon to press a little bit more liquid out. I'll press out as much as I can. Then I'll use a paper towel to press out even more. So I want this as dry as I can make it. I'll press from the top, also wipe it off on the bottom, and then I will set aside the whey, which I do not need. Now keep in mind, this is also mixed with vinegar, so it's not something you want to use. You're going to throw that away when you're all done. Let me set mine aside, and now you can see where the really fun part begins. I can scrape this out, and I have a really awesome, fun substance to play with. See how it forms almost like a Play-Doh? You can make shapes with that. You can make it flat and use cookie cutters to cut it. I'm going to wipe my fingers and get the vinegar and milk off my fingers. I made this little snowman a couple days ago, and I let him sit, and he got really hard. You can hear how hard that got. So let's talk about what happened in this experiment. I'll tip this back up again so I can talk to you. What we did is we made organic plastic. Now, milk is mostly made of water and protein. The main protein in milk is called casein. Normally, those protein molecules in milk are all twisted and folded. But when we add vinegar, which is an acid, those proteins unfold and they rearrange into long, straighter chains that separate from the water. We heated the milk up because heating speeds up the process and makes the separation more complete. So the plastics that we use are not made of milk. They're made from oil, a petroleum product. But the plastic that you get from milk is just as strong as the plastic you get from oil. In fact, before the invention of plastic made from petroleum products, buttons were made from organic plastic that you get from milk. This same process, using different kinds of acid, is also used to make things like buttermilk, yogurt, cheese. In fact, for you cooks out there, if you ever have a recipe that calls for buttermilk and you don't have any buttermilk on hand, you can make your own by adding about a teaspoon or two of lemon juice into a cup of milk. Isn't that fascinating? All right, so we have another quick project here. Our second project, we're going to use vinegar and some salt to clean some pennies. So I'm going to tip the screen back down again so that you can see. Okay, here we go. So have you ever noticed that brand new pennies are very shiny like these two, but older pennies look dirty and dull? In this project, we're going to use vinegar and salt to make a penny look like new again. The first thing we're going to do is we're going to pour about a quarter of a cup of white vinegar into a glass bowl. That's about a quarter of a cup there. Then we're going to put a teaspoon of salt, just regular table salt. Mine's not open yet. Let me grab this, get this to open up. All right, there we go. So now we're going to pour about a teaspoon into the vinegar, and we're going to stir until it completely dissolves. Takes a minute for it to dissolve, but it will. All right, then we're going to take one of these dirty, gross pennies. Look how dirty that is. And we're going to dip it halfway. I'm only doing it halfway because I want you to really be able to compare the two. I'm going to dip it down in the water, in the vinegar and salt mixture, for just about 10 seconds. I'm going to hold it for the count of 10. You want to count with me? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's pull it out and take a look at how much shinier that half of the penny is. Isn't that amazing? Let's try it with one more penny and take a look. So I'm going to stir this up again. Just plain vinegar and salt. And we're going to dip the penny halfway in and count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there you can see the line where the penny got clean on this side and is still dirty on the other side. Now, if you left it in there even a little bit longer, it would get even more shiny and clean. You need to rinse these off, though, because if you just leave the penny covered with vinegar, it will actually turn green because of another chemical reaction that will take place. So let's come back and talk about what happened. So pennies are made of a metal called copper. Copper combines with the oxygen in the air to make a molecule called copper oxide. Copper oxide on the outside of pennies is what makes them look dull and dirty. When I dip the copper penny down into the mixture of salt and vinegar, the mixture dissolved away the copper oxide, leaving only the clean, shiny, new-looking penny behind. Isn't that amazing? All right, we have one more experiment that I think we have time for. So let me clear these things away. And this one takes a couple days to do, so I did it in steps to be able to show you. We're going to use vinegar to dissolve away the shell from an egg. Can you believe we're going to dissolve the shell off an egg and it's still going to look like an egg? So the first thing we're going to do is we're going to take a jar and we're going to take a raw egg. So I'm going to tip this down again so you can see it. Take away our pennies. And we're just using a regular egg, and I'm going to put it down into the jar, and I'm going to cover it with vinegar. Doesn't matter if the egg starts to float. Some eggs will float, some eggs won't. Yep, this one's actually coming up a little bit, but that's okay. And then you're going to set that jar aside somewhere that nobody's going to drink the water from it for about a day, just about 24 hours. After about an hour, take a look at it though. This is what you're going to see. Can you see how this egg is covered with bubbles? Look at the bubbles on the outside of the egg. I hope you can see that well. The bubbles are because of carbon dioxide, which we'll talk about in a minute. So then what happens after about 24 hours? Well, after about 24 hours, the egg looks, look at this. There's foam on the top of the water, on the top of the vinegar, and the egg is down inside there. So I'm going to pour off the liquid. It's tempting to reach in and grab the egg, but remember, there's no shell on this egg, and if you do that, you might actually break the egg right in your hand, and that would be gross. So what we're going to do is we're going to pour off all the liquid and then gently pour the egg out. Look at all the foam on the outside of that egg. Now there's still a little tiny bit of shell, and I can rub bits of that shell off. Now after I wipe all the bits of shell off that egg, look at this egg. It's really squishy. Can you see that? When you do it yourself, you'll be able to really tell that it's really squishy and soft. There's still a couple places where I can feel some hard shell. So the next thing I'm going to do is put that egg back into a clean jar and then fill it up with vinegar again. And then I'm going to leave that for another 24 hours. And what I'm going to get at that point is really amazing. So again, I'm going to pour off the liquid and pour the egg out into my hand, because this is very, very fragile now. Look at this egg. Look how much bigger that egg is than it was before. And look, I'm still wiping bits of foam and shell off the egg. Isn't that amazing? And look, you can really see how my finger squishes down into the egg, causing it to bend. It's not hard like before, like had a hard shell. So now we're going to put this one aside, and we're going to tip this back up and talk about what happened. All right, let me tip the screen back up. All right, so what happened with this egg? Well, that's the amazing part about science. The shells of eggs are made of a substance called calcium carbonate. When I put the vinegar into the jar with the egg, I started a chemical reaction that dissolved away all the calcium carbonate in the shell. The bubbles formed on the outside of the shell because in the process, that chemical reaction produced carbon dioxide gas. But you might wonder why the egg didn't break when the shell was dissolved away. Well, just inside the shell, there are two thin membranes. Those membranes protect the baby bird as it grows, and they're strong enough to keep the inside of the egg inside the egg. So I want to thank you for joining me as we discovered the cool things that you can do with just such an ordinary substance as vinegar. Vinegar really is an amazing thing to experiment with and play with. So next week, we're going to see what fun things happen when we mix vinegar with baking soda. I hope you can join me for that. I want to make these AIM Science Facebook events fun and meaningful for you. So if you have any topics that you'd like to learn, please just leave me a comment and I will see if I can get to them. So I thank you all for coming, and I hope you have a wonderful week. Please don't forget to look for the science that is all around you every day. Bye.